Okay, so kinematics of one dimension. Now, many of you, I'm hoping, took the grade 10 enriched science, which means that you probably saw a little bit more in the physics to get you ready for, or the motion unit to get you ready for physics. You're going to find some of the initial bits all reviewed, but that's just for me to sort of make sure that everyone's on the same page and to catch up those that didn't get the enriched. So bear with me here. Motion of objects, baseballs, automobiles, joggers, even the sun and moon is an obvious part of everyday life. And in fact, most people think that motion is, that's it in the physics, right? Not true. Motion was undoubtedly the first aspect of the physical world to be thoroughly studied, and this study can be traced back to the ancient civilizations of Asia Minor. We're talking about the Persian Gulf area, Egypt, those areas. Although the ancients acquired significant insight into motion, it was not until comparatively recently, in the 16th and 17th centuries, that our modern understanding of motion was established. Many contributed to this understanding, but as we shall soon see, two individuals stand out above the rest, Galileo Galilei and Isaac Newton. And oddly enough, Galileo died the same year that Newton was born. The study of the motion of objects and the related concepts of force and energy forms the field called mechanics. Notice that it is in bold. It is a definition that you should be aware of. Once again, my highlighter has disappeared. It's over here, I think, right? There we go. Mechanics. Yes, yellow. Mechanics. Mechanics is customarily divided into two parts. Kinematics, which is a description of how objects move, and the second part is dynamics, which deals with why they move. Traditionally, in grade 11, we deal with kinematics as a unit, which is what we're going to do, and then dynamics is the next one, forces and all that stuff. Okay? Grade 12, we tend to lump it together. This unit deals with kinematics. We start by describing, we start by discussing objects that move without rotating. Such motion is called translational motion. You may have studied translations in math class, moving from one spot to another without any rotating. Okay? To make things simple, we're going to be talking about train tracks and bikes and people walking, no one rotating. We're not talking about footballs doing loopy-loops or curved balls or anything like that. Simple, from point A to point B, translational motion. We will be mainly concerned with describing an object that moves along a straight line path, which we call one-dimensional, right? One dimension, or rectilinear motion. In grade 12, we do deal with two-dimensional motion called projectile motion. It's a lot of fun. In grade 12, there we go. Okay, so speed. Speed and velocity are words that are often used interchangeably in everyday language. In physics, we make a distinction between them. For now, we discuss only speed, which refers to how far an object travels in a given time interval. If a car travels 240 kilometers in 3 hours, we say that its average speed is 80. In general, the average speed of an object is defined as the distance traveled divided by the time it takes to travel this distance. And the definition, or the formula for speed, is we use v for velocity. Speed, velocity are kind of interchangeable in the formula sense. V equals d over t, and I'm hoping that you remember that from grade 10. What you may not have seen in grade 10 is the little bar. Did you guys see the bar over the V? Yeah? Who saw the bar over the V? Two of you? Who knows what the, Jordan, do you know what the bar over the V means?
What's in motion?
No?
That's correct.
Keenan? Good guess, but no.
That's correct.
No, actually no. That would be, means average. Very good. In fact, the bar over anything means average. It's a statistics thing. Okay, so it means average velocity. Average velocity, exactly. So in this case here, I've got 240 and I've got 80. My displacement or my distance is, oh, crying out loud. This computer, you are getting a restart after this. 240 over time. No, time was 3, wasn't it? Yes, sir. Oh, this. Please notice, formula, substitution, answer. That's what I want. I want to see the formula, I want to see you putting the numbers in the right spot, and I want to see the answer. Because if you do this, and then you do this, and then you do something stupid like 240 divided by 3, and you write I don't know, but this happens. It happens all the time. Kids write 240 divided by 3, but then they punch in 240 divided by 4. And how am I supposed to know? If all I see is the 60, guess what? Big, fat 0, they don't know what they're doing. If I see d bar equals d over t, and then I see 240 divided by 3, and then I see 60, I can use my little brain and figure out they probably divided by 4. I'm going to give them a mark here. If you catch me on a good day, I might even give you full marks. That part is important, Anderson. He smiles at me because he knows why I'm taking my marker right now. D stands for the distance, T is for the elapsed time for the speed. The bar over the V is the standard symbol meaning average. Now, normally, I would get out the clickers and do all that, but considering there's only like about 4 or 5 minutes left here, probably not enough time. Can we just do this manually? No. Just do it right now. Just do it manually. Come on, you can do it. Go ahead. Go ahead. You guys don't have this written on the sheet, do you?
Yeah.
You don't have the question, though, do you? Or do you? You do have the question? Okay, I don't care about the answer. I care more about the process. So go ahead. Go. Write it down. Okay, let's do this together. Your first thing you should do is write the formula. How far can a cyclist travel in 4 hours if his average speed is 11.5? You should write v bar equals d over t. If you didn't write the formula, you're a bad person.
Oh, Jason. That's fair.
Plug in the values. What is v bar? 11.5.
Oh.
Please plug in your values directly below where you wrote down the formula. Do not do this. That some people... Is there no undo? No, there's not.
Unedit.
Unedit?
Yeah. So, that's view. The other edit button.
Oh. You're right. Do not do this. For whatever reason, people want to do this. They make like a little angle thingy. Why are you doing that? Some people do this. This comes from trying to save as much paper as possible in junior high. Please get out of that habit. Okay? My own son was like, he would try to, I think he went through 12 sheets of paper in 2 years. Stop doing that. Put the numbers directly below. The equal sign should actually line up. Okay, I'm looking for displacement. I leave the D, I fill in the value of time. Solving these little things has to be automatic for you. Okay, it may not be yet, but you have to know automatically what to do here. You multiply, right? 4 times 11.5. 2 times 11.5 is 22 plus 1 is 23. So 4 times would be 46 what? I've got kilometers and hours. Kilometers. You may have had Mr. Friesen talk about dimensional analysis. Yay, I usually get a big cheer when that happens. So actually what you've got here is technically you would have D equals 4 hours times 11.5 kilometers per hour, and the hours cancel, leaving you with kilometers. That's how you know.
You try to explain that, but you did a really crappy job at it. You made it way more complex.
It can be very complex. It doesn't have to be. Okay? Your answer should be 46. Who got it right? Who showed all their work nice and neat?
Yep. But I say paper.